Hello everyone. In this video I am going to present SUDAF. First, let us recall the concept of user-defined aggregate functions. Modern systems enable users to extend the system functionalities by defining their aggregations. The UDAF mechanism provides a flexible interface to do this, like creating advanced statistical functions or ML workloads. However, creating UDAFs requires users to override the initial function, the update function, the merge function and the finalize function. Moreover, the hard-coded UDAFs are black boxes to a query engine, which hinders optimization opportunities. To overcome these issues, we designed the SUDAF framework. SUDAF is a declarative framework, which means UDAFs can be created by declaratively defining their mathematical expressions. SUDAF adopts two approaches to optimize computations of UDAFs. The first one is to rewrite partial aggregates of UDAFs using built-in functions. The second one is to cache partial aggregates and reuse them for computing different UDAFs. As we will show later in our demo, both of these two approaches can speed up the execution time of queries with UDAFs significantly. This figure shows the SUDAF workflow. Generally, SUDAF exploits expressions of UDAFs to factor out partial aggregates. Then, SUDAF analyzes partial aggregates to optimize their computations. Partial aggregates can be computed either using SUDAF caches or by rewriting using built-in functions. In our demo, we present the following two scenarios: creating UDAFs, executing queries with UDAFs, and visualize running times, where we will separately demonstrate the rewriting and sharing approach adopted by SUDAF. We use Spark SQL as a baseline system to show an end-to-end comparison. Now, let us go to see the SUDAF web UI built on top of Apache Zeppelin. First, let me import the Milan telecommunication dataset that I am going to use, which contains 319 million tuples. Let us see the first scenario of creating UDAFs. We use the quadratic mean as an example to show how to create a UDAF in Spark SQL. In SUDAF, there are two ways to create UDAFs. The first one is using the SUDAF graphical interface, which provides buttons for primitive functions in SUDAF, and users can click these buttons to define expressions of aggregations. The second way is writing one line of Scala code, which represents expressions of aggregations, as shown in this paragraph. We also show some other examples. Here, we create an average, a sample variance and an approximate median, which we will use later in our demo. SUDAF uses the moment sketch to approximate a percentile, like median, which can provide more sharing opportunities. Now, let us see the second scenario about executing workloads of queries and visualize their running times. We provide an object called workload, where users can insert queries and run them in Spark SQL and SUDAF. The workload object can capture running times of queries. Let me first demonstrate the rewriting approach in SUDAF. Let me insert and run the first query with the quadratic mean that we created previously. These two paragraphs shows its execution in Spark SQL and SUDAF. Let us see the running time. SUDAF provides a 2 times speedup for this query. This is because of rewriting partial aggregates of the quadratic mean using built-in functions. Let us see the details in their execution plans. The left side shows its execution plan in Spark SQL and the right side shows its plan in SUDAF. We can see here the partial aggregates of the quadratic mean are rewritten by SUDAF using built-in aggregations, and the hash aggregate for computing them can be included in whole stage code generation. Now, let me demonstrate the sharing approach in SUDAF. Let me insert and execute the second query with the average and the third query with the sample variance in this workload. We can visualize the running time of these queries here. For the second query with the average, SUDAF has the almost identical running time as Spark SQL. This is because the average is a built-in function, and at the time of computing it in this workload, SUDAF caches cannot be reused to compute partial aggregates of the aggregation average. For the third query with the sample variance, its running time in SUDAF is significantly reduced, because SUDAF reuses the computation results of the first two queries. Let us compare the execution plans of the third query in Spark SQL and SUDAF. The left side shows the plan in Spark SQL and the right side shows the plan in SUDAF. We can see that the third query in SUDAF is fully computed from SUDAF caches without any data scanning and hash aggregate. We can also visualize the total running time of this workload. SUDAF is 2 times faster than Spark SQL. We also show another example where we demonstrate that the intermediate results of the approximate median implemented using moment sketch can be shared by SUDAF to compute the quadratic mean, the average, and the sample variance. In this workload, the sharing approach significantly speeded up query running times. Thanks for your attention. Bye.